everyone. Good morning. Dear authors and invited guests, I welcome you all to the technical session 6E. Myself, Siddesh Mokul, and this session will be moderated by me. On the behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 9th International Conference on Information Communication Technology and Intelligent System ICTIS 2025, Bangkok, Thailand. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, Thailand, and the virtual event is being held through Zoom today and tomorrow, that is 5th and 6th April 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you will all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Okay, so just before we start the session, I would like to introduce you all to the chair of this session. Our chair for this session is Dr. Namrata Nishant Vasatkar. Dr. Namrata Nishant Vasatkar is an assistant professor at Vishwakarma Institute of Information Technology, Pune, India. With over 12 years of academic experience, she has published more than 20 papers in national and international conferences and journals. Her expertise lies in artificial intelligence, data science, natural language processing, and computer engineering. Ma'am, would you like to give any opening remarks to the participants?
No, thank you, Siddesh. Just wish you all the best to everyone. Yeah, please start. We will start.
Okay, ma'am. Thank you. So, the first presentation is presented by uh, Shiren Kausar. She is presenting the paper title, A Comparative Study of Otsu Threshold and GradCup for Image Segmentation on Dataset of Paralysis Affected Patients. Shirin, are you in meeting?
Yes, sir.
Okay, so you can start your presentation, Shirin.
Okay. Good morning, everyone. So my paper is titled with a comparative study of OTSO thresholding and graph cut for image segmentation on data sets of paralysis affected patients. So starting with the what is image segmentation, the process of dividing an image into multiple regions or segments that is often based on the similarities in pixel characteristics like texture, color, brightness, or the boundaries to identify the objects. So in medical imaging, the image segmentation is very critical. That is done by using computer vision. So many methods have been used for image segmentation. So here in my paper, we are basically concentrating on OTSO method and the graph cut method, which are two widely used segmentation techniques. So in this study, we compare their performance, accuracy, speed, and complexity handling, particularly for analyzing the paralysis affected patients data set. As my research is mainly focused on paralysis affected patients. So what is the importance of segmentation in paralysis affected patients are? So the stroke analysis, it is to identify the hemorrhagic regions in the brain scans and the muscle atrophy detection where MRI segmentation of the muscular tissues are done, and the nerve damage identification, that is detecting the nerve fiber which is degraded, and rehabilitation monitoring, that is tracking muscles and nerve healing. So these are the basically on paralysis affected patients. So the main objective here is to analyze the effectiveness of the outsource method and the graph cut method, and to
Excuse me. Your presentation is not in slideshow mode, I think. I can see only first slide of the presentation.
now, ma'am.
Yes, now it's visible. Yeah, please continue. Thank you.
Okay. So the main objective are the analyzing the effectiveness of the outsource method and the graph cut method, and evaluating their performance in the medical image segmentation and comparing their accuracy, efficiency, and the suitability for the different image types. So what is auto thresholding? Auto thresholding is a histogram-based thresholding technique that maximizes interclass variance to separate foreground and the background. So what histogram is? It is basically a graphical representation showing the frequency distribution of the pixel intensity values in an image, providing insights into the brightness, contrast, and the overall pixel distribution. So image histogram is basically a grayscale value that distribute showing the frequency of the occurrence of each gray level value. So here it is foundation is the maximization of the pixel intensities between class variance and minimization of their within class variance. The best threshold values for binarizing an image is found using auto approach, which is particularly helpful for photos with biomodel histogram. That is, biomodel histogram is that display a distribution with two distinct peaks indicating the presence of two separate groups of single data set. Also thresholding method, this is the method what it includes. It's determining the optimal threshold for the image segmentation, and it maximizes the interclass variance and minimize intraclass variance. Best suited for images with biomodel intensity histogram, that is with two separate groups in a single data set. Fast computation, but it is sensitive to the background noise. So what is this advantages and limitation? It is simple. The advantages are, it is simple, computationally efficient, works well for the biomodel histogram. The limitations are images that have overlapping intensity distribution, it struggle to segment those images, and it is sensitive to background noise. So the graph cut algorithm it is common technique for removing four background from an image. It is graph cut segmentation algorithm. So Gaussian mixture model, GMMS, and graph cuts serve as the foundation for effective and precise picture segmentation. And it is also an iterative segmentation method which uses the graph cuts to refine segmentation of foreground and the background. So the methods are graph cut segmentation algorithms. It uses a Gaussian mixture model and the graph cuts. It improves segmentation accuracy. It requires user-defined bounding box for initialization. And computationally, it is more intensive than auto method. Its advantages are, it handles complex images better than auto method. It allows interaction for refinement, and limitations are, requires an initial bounding box, and it is more computationally intensive. So data set here for the image segmentation we have used are, we have collected a medical images of paralysis affected patient, which is captured using imaging techniques. So for mainly we have made a survey. We have visited a paralysis affected center, and I personally collected these images, and on these images I have made both graph cut method segmentation and auto method segmentation. Next, the comparative between auto and graph cut is, auto is a fast, automatic, ideal for different types of images. Graph cut is more accurate with complex images, but it is slower in the speed for segmentation. Graph cut is less sensitive to noise, and auto is more sensitive to background noise. So the trade-off between computational time and the segmentation accuracy. Auto is suitable for simple and well-separated images, whereas graph cut is suitable for more complex images. Graph cut is more advanced and useful for detailed and noisy images, and graph cut generally outperform auto in challenging medical image segmentation task. So the result, we can say that also perform well on simple high contrast images, whereas GrabCut performs on effectively complex noisy images with unclear boundaries. Graph-based segmentation methods like GrabCut shows superior result. Segmentation accuracy is GrabCut outperform also on complex images. Computational time is faster for also to single-step processing. Challenges are also struggles with multi-region segmentation. GrabCut requires user input, which can introduce bias. Computation time for GrabCut is higher than OTSO. So conclusion we can made as OTSO method is more efficient, but it is limited to simple cases. But GrabCut provide more accuracy at the cost of higher computation. And GrabCut work for complex images, which is less sensitive to noise and also is more sensitive to noise. Choosing the right method depends on the complexity of the images. Thank you.
Yes, nice presentation, Shirin. Just is any existing work is done similar kind of this?
Similar kind of work, ma'am, different types of segmentation method has been compared. For
Okay,
my research purpose, I have particularly chosen only two methods, that is GrabCut and OTSO.
okay. So you are in result and discussion. You said you are comparatively you are comparing the two methods. So there is any metric for comparative?
Yes. Yeah, ma'am. The matrix for the comparison are like accuracy, noisy background, and time taken for the segmentation.
Have you implemented this in practically?
Yes, ma'am, I have implemented. That's
Then
result I have included.
yes. So in results and discussion, you have to show the some numbers or graph something. Don't write text. Okay.
Okay, well,
So when you are comparing, you have
I
to
have
show which one
included in
is.
the paper.
Yes, in presentation also you have to,
Oh,
when you are
okay, ma'am.
comparing, you have to compare with some numbers or some graphs. Okay.
Okay, sure. Okay, ma'am.
So what is difference between this two graph cut method
So
and
also
what's the
method
method?
is using grayscale levels, ma'am.
So
Whereas
which one
grab
is
cut,
better?
ma'am, depending upon the complexity of the image, ma'am. So if the background is clear, the also performs well, ma'am. If the background is not clear, then the grab cut method can be implemented.
Okay, and what is the application of your problem statement?
My main research work is to identify and prevent the paralysis affected patient, that is early detection of the paralysis. So here we have used the data set of the paralysis affected patient. Now the segmentation part I am working on. The next part will be feature extraction part now.
Okay, fine. Yes. Thank you. Thank you, Shirin.
Oh, thank you so much, ma'am.
Thank you, Sharon.
Thank you, sir.
Up next, we have Yash Kulkarni, and he is presenting the paper title A Comprehensive Approach to Retrofittable ADAS for Heavy Vehicles. Yash, are you there in a meeting?
Yeah, I'm here.
Okay, sir, you can start.
Screen sharing, I guess, is disabled.
You can try again.
Yeah. Is my screen properly visible?
Yeah, it's visible.
Okay. And just to confirm, you are able to see the different slides, right? When I'm navigating.
Yeah.
Okay. So, good afternoon, everyone. I'm Yash Kulkarni. I'm an alumni of MIT World Peace University, Pune. And I work as a software engineer right now, a computer vision engineer. And this is the paper which I had written in my final year, which I'm presenting right now. So it is titled as a comprehensive approach to retrofittable ADAS for heavy vehicles. and it is co-authored by my colleagues Parth Chavan and Parth Sarke, and two faculty members, Professor Rupali Kute and Professor Dr. Vinaya Gohokar ma'am. So let's start. If we have to summarize the entire paper, the entire things that we have done, we can summarize it in one line as we have developed a cost-effective retrofitable ADAS. For those of you who don't know, ADAS is Advanced Driver Assistance System. So it is basically a system which helps drivers, car drivers, vehicle drivers, to take informed decisions based on some feedback received from sensors on the street. So we have developed a cost-effective retrofitable ADAS which delivers real-time object detection and enhanced situational awareness. So here, cost-effective and real-time are the two important words or our USPs. This is the agenda. All of these topics, right from the introduction of our paper till the conclusion and future work I'll be presenting today. So ADAS is very essential on streets in reducing human error. So it is an essential system in each and every vehicle. It provides timely alerts and it enhances the awareness of the driver for its surrounding. And especially in environments like India, where there are many variables present, we need these types of systems to take better decisions on the road and to avoid hazards. And in our study, we are specifically focusing on heavy vehicles. So heavy vehicles are more prone to accidents because of the blind spots that are present on a vehicle, because of their size and the conditions on streets, especially in India. So our study revolves around these keywords. So the blind spot I was talking about in heavy vehicles, there are blind spots present in a heavy vehicle, four on each four sides of the vehicle. We are specifically focusing on the front and left blind spot out of the four, which are front, left, right, and back. And we have deployed a retrofitable system with a high frame per second performance. So frame per second is something which you measure to get the speed of the inference of our system. So FPS is the metric which we are using here, and it is associated with the latency of the system. So our objective is to develop a retrofitable ADAS. So it should not be something that we have to install on the system of the vehicle, or collaborate with the manufacturer. We can directly sell it to the customer. We can directly fit it inside the cabin without making any adjustments or modifying the vehicle as such. So that's what retrofitable means. And we have developed it. We have used a optimized YOLO Wi-Fi model and achieved a good FPS, which I will talk about in the results and all. And we have used a Jetson Nano platform to build a prototype of all of this. And another objective is to enhance the situational awareness. So we have not just streamed the video, we have given some type of collision alerts, and we have used a data set especially tailored for Indian traffic data set. So that is DATS 2022. It is a data set from our college itself. So I'll talk about that in the later slides, but this data set is used along with another custom data set, which is for traffic sign detection. So these two data sets have been used to give the driver informed alerts about whatever is happening in the surrounding, along with the video feed, of course. So our contributions to this particular study are, as I said, first of all, it's retrofitable. Our system is retrofitable. It easily integrates into existing heavy vehicles and their systems. Then we have optimized the camera position. We are specially focusing on the right-hand driver configuration, which is present in India. And we are addressing the blind spots that are related to that driving configuration. We are also providing small features which add up to the safety of the driver and the vehicle and the people around him. Something like relative distance measurement also we have added. So that's one thing. Then real-time performance, as I talked about, we have made it cost effective as well as it's performing well on a cost effective system. So, of course, we have conducted thorough literature review. Around 20 plus papers we have reviewed, and currently systems are there which do one of these things. Either they provide a 360-degree view, but there is some lack in the situational awareness part. It might be present, but it's not cost effective. So that might be a lack in the current approaches. uh, then we also need something that is lightweight. It is able to process video feed in real time. We have also created an Android app which can be used instead of a HMI. So HMI is something that we place in the driver's cockpit, wherein he will be able to see all the video feeds and the alerts on a screen. So if he is not able to afford that screen, we have a Android app using which you can directly stream the video on your phone and integrate it with our system. So we are aware of the research gaps, and we have hence tried to make our research in a way that we address them. So if you look at this image, the block diagram of our proposed system, it will give a complete overview of what all we have done. So you can see there is a truck, there is a camera at the front, there is a camera to the left. So front and left blind spots are covered. There will be a Jetson Nano attached in the driver's cockpit, wherein we'll have streaming video streaming present through V4L2 backend. And we have used technologies like TensorRT and CUDA to optimize the FPS performance, and a YOLO V5 model. This model, why we have chosen, I'll get to it in a few slides, but this model we have chosen for our system. Then we have a HMI that is attached to the Jetson Nano, which will be the screen that will give all the alerts. If the driver wishes not to use that screen, we have a Android app. So all the streaming to the Android app is done through WebSockets protocol. So this particular diagram you can have a look at. The two data sets I had talked about, that's 2022 and a custom traffic sign data set. So around 10,000 images we have trained our models on, and we have classes especially tailored for Indian scenarios like pedestrians, vehicles, trees, as well as animals. So uh, this is the whole thing, the system. So as I talked about, we are deploying the system on a NVIDIA Jetson Nano with 4 GB RAM and 128 CUDA cores, quad core ARM Cortex architecture, and the software
Sorry
stack that we
to
are using. Yeah,
interrupt, sir, but your 9 minutes are over, so
all
you
right,
can wrap
all
up
right.
here.
So some standard augmentations we have applied, and we have trained our model with 100 epochs. And this is our collision alert and relative distance measurement system. So we have created kind of a trapezium. We are looking at the distance of the detected object, and we are giving some alerts and warnings on the GUI. So this is the GUI. You can have a look at it. We can toggle between the left and front screens, and we have the proximity alert along with the sign that is detected on the road. So it's quite a simple system. Moving to the results, we have achieved around 12 FPS with accuracy of 80 plus percent, average accuracy of 80 plus percent, and a consistent training and validation loss. Also, our system is efficient, especially in terms of low latency data streaming, both on the Android and HMI. And yeah, we have incorporated all of this together. And the reason behind using YOLO V5 is because of the optimizations that we got to do with that particular algorithm, especially for the FPS. So to the left, you have a comparison of how we have increased the FPS by using different technologies and software layers. So that was for the results. And talking about the summary of my presentation, I guess I don't need to do that because it was too short. But what we can do ahead of this is we can integrate a 360-degree view into our system. We can optimize it for accuracy and FPS, and we can perform better testing, especially with users. So that's it for my presentation. Do let me know if you have any questions.
Yes, thank you, Yash. Nice presentation it was. Uh,
Thank you.
just one thing. What is your contribution when you in as compared to your existing work?
contribution of this particular system. So, as we have highlighted, there are gaps in research, especially around using all of these systems, making it cost effective, making it retrofitable. So, we have developed this system in a way that it's especially tailored for Indian roads. We have used a unique data set. We have used technologies that are not used in this particular area, especially for optimizing and making it cost effective.
Cost effective means how much you are saving?
Cost effective, the cost associated with this will be mainly around the processor, that's Jetson Nano. So the cost varies around, I think, 16,000 INR to 20,000, I guess. So that's the only cost of, associated with it. Existing systems cost around, I would say, higher than 50,000 INR. So that's where we have improved along with the FPS and the features, especially tailored to the Indian roads.
Okay. Have you tried on Indian roads in practical way or live?
Yeah, so some testing has been done. It has not been carried out in a heavy vehicle, but we have carried out in smaller prototypes. So yeah, that has been done.
Any challenges you are facing?
Challenges, especially when we go and optimize the FPS, as I said, there will be some compromise in the accuracy. So we'll have to work around improving the accuracy a bit.
Okay, fine. Yes. Thank you.
Thank you.
Thank you, Yash.
Thank you.
Moving further, we have Tirth Thinsniom. He is presenting the paper title Analysis of Abnormal Driver Behavior from Gaze Detect Direction and Blinking. Tirth, you are here?
Okay, let me share the slide.
Okay, just a second. Yeah, now you can share your slide.
Okay. Hello everyone, my name is Thiratiniyom. I'm studying Master Degree Correction of Digital Innovation Technology, Langset University in Thailand. Today I would like to present about analysis of abnormal driver behavior from grace direction and blinking. Let's start introduction. First, driving require concentration and quick decision making, especially looking left and right to avoid danger. And the second, driving while dosy reduce reaction time and increase the risk of accident. And And third, eye tracking technology such as OpenCV and MediaPi to help detect the grace, analyzing grace and blinking. Our goal is to develop an algorithm called UDAF to detect abnormal driver behavior such as dodginess and initiation using eye direction and eye blinking as the main indicator. This slide provides an overview of our entire process, starting from data correction on Kaggle, pre-processing the data, normalizing and increase contrast, and moving to direction with OpenCV and MediaPi iris for eye detection and ring detection. Then use the VGG16 model to extract features which are processed by the LSTM model to analyze the driver behavior. And finally, we integrate the result into the UDAF equation to assess the driver alertness. I will explain the detail in the next slide. Pre-processing first dataset. I utilize 60 images depicting left, right, and forward grace, along with 20 video clips demonstrating gas direction and blinking behavior. All samples were sourced from Kaggle.com. The dataset was divided into 3 subsets: 70% for training, 20% for validation, and 10% for testing. The training set was used to train the model, and the validation set was used to fine-tune the model during training, and the test set was used to evaluate in the model performance on unseen data. Number 2, normalization. Min-max scaling method normalize data within the range between 0 and 1 by subtracting the minimum value and dividing by range. This reduces feature imbalance, enhance computational efficiency, and prevent outfitting. And number 3, histogram equalization. This technical distribute pixel in sensitive frequency to increase image contrast and enhance feature detection. Is particularly effective for improved low contrast or underexposed image, making a feature more distinct. This slide technical detection technical skip development in this step using Python with library called OpenCV and MediaPy. OpenCV handle the image such as opening file, capturing facets, and cutting out design area. MediaPy, especially the module called IRIS, help us detect the position of the eyes in great detail. The system reads the image from the video frame by frame and analyze which way the eyes are looking left, right, or straight ahead. It also counts the number of times the driver blinks using the eye aspect ratio detection. The data obtained from starting from blinking in each frame will be recorded to be used to validate the driver behavior in the next step. This research used a VGG16 model to train image database to extract feature from driver video frame focusing on eye blink and grace direction. After extracting feature, we use an LSTM network to predict the blink frequency and direction. The experimental results show that VGG16 and LSTM can accurately detect eye blinks and grace direction, and LSTM help analyze the temporal pattern of change according to driver behavior. After testing system with still image, the next step is to experiment with 10 real video clips, each for which is about 30 seconds to 2 minutes long, reflecting the real-world driving situation. For each clip, we let the system detect the driver behavior in real time, including the direction of the driver grace and the number count time they blink. Then we process the obtained data such as grade and blink together at different times to further analyze. Key finding and result from the detection result graph showing the driver behavior detection result, it can be observed that the yellow line show the blink rate, which is high in some area, especially during period of frequent and prolonged blinking, indicating fatigue or lack of concentration of the driver. Meanwhile, the blue line, gray line, and orange line show looking different direction. For alert driver, you will see the looking behavior is balanced between looking to the left, right, and straight ahead with a relative normal blinking rate. If for triad driver, it can be seen that there is polygon fixation in one direction and increased blinking, especially in some areas such as in video sequence 17 and 18 indicating fatigue. The obtained UDAF value are then used to classify low, moderate, and high based on certain criteria. If it is low, blink rate is less than equal to 30 times per minute. If it is moderate, blink rate is between 30 and 50 times per minute. And if it is high, blink rate is more than 50 times per minute. And this graph shows the F1 score for both grace direction and the UDAF equation, which include high aspect ratio, grace direction, head turn, and fatigue level. The UDAF equation can comprehensively assess the driver alertness. We can see that the UDAF equation often perform better than grace directions specific grace, especially in sequence with abnormal behaviors such as prolonged grace or high bring rate. This shows the incorporating factors such as bring and grace improve the model accuracy in identifying abnormal driving state over time with an average of 93.12%. In conclusion, in this graph, the red line in the graph let's present the direction of eye blink, while the purple frame indicate the onset of abnormal driving behavior, which is marked when there are more than 20 blinks within 60 seconds, indicating dulcinate or fatigue. Our system can detect abnormal driver behaviors with an accuracy of 93.12%, proving that the direction of grace direction and eye blink can effectively identify abnormal driver. Thank you for your attention.
Yes, thank you. What is UDF?
The U okay. The UDAF is combined with eye detect and eye blink. Eye detect when you see the get left, get right, forward, and blink left to combine with the UDAF.
Okay. How many images have you used for the model training?
Uh, Again.
How many images have you used for model training?
I use the 16 image and I use the 20 video clip. I use image video frame by frame and I make sure this data set have more perform this project.
Okay. So what is the next plan? Means what is the future scope for this project? How you can improve the accuracy for this model?
And future work I think I think I need to find a more data set to train for this research in the future because I need to 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 develop the research in the future.
Okay, okay, fine. Thank you.
Yes,
Thank you
thank
so
you.
much. Yeah.
Thank you. Next, we have Sukleef Kaur. She is presenting the paper titled Cardiac Hypertrophy Detection Using ResNet 50, a Deep Learning Approach. Sukleef, are you here?
Okay, I'm here. So wait for a
Okay, okay,
second.
just
I
a
will
second.
share the slide for you.
Yeah, sure.
Hello, everyone. I am from College of Digital Innovation Technology, Transit University, and so I am Sok Liu Kuo, and today I am honored to present about my title is Cardiac Hypertrophy Detection Using ResNet 50, a deep learning approach. Cardiac hypertrophy is a condition where the heart muscle thickens abnormally, reducing its pumping efficiency. If left undetected, it can lead to serious complications such as heart failure. Early detection is crucial as it allows for timely intervention like lifestyle change or medication, which can significantly slow the progressing of the disease. Imaging methods such as chest X-ray are commonly used to detect this condition. About the motivation of the research is transitional decision through chest X-ray is time consuming, and can be subjective. Radiologists may have different interpretations, which led to inconsistency. Deep learning, on the other hand, provide a fast, consistent, and accurate approach to medical image analysis. This motivated us to apply a deep learning model to support cardiomegaly detection. About the architecture of the SASB is our goal is to enhance the efficiency and accuracy of detection cardiomegaly from chest X-ray using deep learning, supported by image processing techniques. Specifically, we apply a combination of clouds, color histogram analysis, and also trend holding, along with the powerful ResNet 50 model for classification. To train and test our model, we use a large and publicly available dataset. We utilize the NIM chest X-ray dataset with content over 112,000 chest X-ray images. For this study, we focus on the Toronto's view and divide the dataset into training, validation, and testing set in 70, 20, and 10 ratio. This approach ensured that the model was trained and evaluated on a comprehensive and well-balanced dataset. Our methodology being with image enhancement using clouds, followed by two key feature extraction methods is color histogram and also trend holding. The results from this method are converted into tensor and fused to form a comprehensive input for the ResNet 50 model, which perform the final classification. Intro is image processing step starting with clouds is a stand for contrast limited adaptive histogram equalization is it enhance can contrast in the X-ray image, especially in areas with subtle difference in brightness, like the heart and lung regions. This method ensures we can visualize the size and shape of the heart more clearly, which is vital for the detection cardiomegaly. Once the contrast is enhanced, the next step involves analyzing pixel brightness through histogram. A color histogram gives insight into how pixel intensities are distributed across the image. When the heart is enlarged, the brightness pattern in that region changes. Histogram analysis help the model learn and detect this difference. This makes the model more accurate in distinguishing between normal and abnormal heart condition. After brightness analysis, we apply an automatic trend holding technique to segment key image region. Also, trend holding automatically separate important image feature from the background by converting grayscale image into binary format. This process highlights critical structure like the heart and lungs, making it easier for the model to detect abnormalities related to cardiomegaly. Once the features are extracted, they need to be formatted for deep learning model. This is where tensor encoding comes in. In this step, the output of the color histogram and also trend holding are converted into tensor multidimensional array used by neural network. This tensor preserves both color and structural data forming a comprehensive input that the deep learning model can efficiently process. And the next step involves combining this picture into a single powerful representation. We force the data from both method, color level, and structural analysis into one input. This fusion helps the model understand both visual appearance and shape-related characteristics of the heart. With richer data, the model is better equal to classify whether a patient has cardiomyopathy. About this is the experimental results in this research after using our model in cardiomyopathy. For cases with cardiac enlargement detected, we achieved 82% of sensitivity, 88% of accuracy, and 90% of precision, with an 88% of L1 score and 90% of MAP. This indicates strong performance in identifying positive cases. And another one in case with no cardiac enlargement detected, sensitivity was 66%, accuracy 83%, and precision was high at 98%. The L1 score was 79% and MAP was 88%. The high precision here means the model is very reliable when prediction the option of cardiomyopathy. In the conclusion, in hand with image processing techniques, our resonate-PT model shows strong capability in detection cardiac enlargement when predicting cardiac enlargement detected. The model achieves a precision of 90% and a mean average precision is MAP of 90% also, demonstrating its reliability in positive identification for cases predicted as no cardiac enlargement detected. Sensitivity was 66%, but precision reached 98%, suggesting a low occurrence of false negative. Overall, the finding underscore the model promise a system the diagnosis of cardiac hypertrophy using X-ray image. And thank you for your attention and welcome for the question.
Yes, thank you. Why do you use Resonate 50?
I using ResNet 50 because ResNet 50 is a powerful and widely used convolution neural known for its efficiency in image classification tests and is after the Valencian Gradient problem allow for the training of deeper network and achieve a high accuracy.
Okay, and what is your loss function for binary classification?
Excuse me, can you ask me again?
What is the loss function you are using for binary classification?
The function that I use in this research is I use for the color histogram with the um, and with the also trend holding.
So up next we have Latika Savni. She's presenting paper title Exploring Cognitive Load in 2D and VR Science Learning Environments, a discourse analysis approach. Latika ma'am, are you here?
Yes, I'm here. Thank you so much.
Okay,
I'll
ma'am, you
just
can
share my
start.
screen. Yeah. Okay. My greetings to all the distinguished attendees of this conference. It is wonderful to connect with you all. My name is Latika Sahani, and I would like to take this privilege to present my research work. The title of our paper is Exploring Cognitive Load in 2D and VR Science Learning Environments, a Discourse Analysis Approach. As metaverse continues to redefine digital interaction, virtual reality is becoming a powerful tool in education. While its impact is well recognized in STEM learning, its
Sorry
integration
to
into
interrupt,
K
ma'am.
12.
Just
Yes, ma'am.
your presentation is not in
Yeah,
slide.
just so.
Yeah.
Okay. So, while the impact of virtual reality is well recognized in STEM learning, its integration into K 12 classrooms and its cognitive effects on students remain underexplored. So, in this study, we explored how 2D and VR science learning environments could influence engagement, cognitive load, and instructional design to provide insight into optimizing immersive education for better learning outcomes. Have you ever tried to struggle have you ever struggled through a complex concept, feeling that your mind is working overtime just to keep at it? Now, this is cognitive load in action. So, cognitive load is actually a mental effort which is used to process new information. Now, imagine learning science in two different ways, one through 2D traditional screen and the other through VR immersive environment. Which would help students to learn better and why? We try to explore these questions with the lens of cognitive load theory, which is given by John Sweller, and it says that the cognitive load is the mental effort in the working memory during learning. It categorizes cognitive load into three types: intrinsic load, which comes from the inherent difficulty of the material being learned; extraneous load, which is the unnecessary effort that goes into learning; and germane load, which comes from understanding, structuring, and processing information to enhance learning and keep it in the long term memory. Now, why we systematically explored 2D and VR learning environments to understand its impact on students' cognitive processes. Now, why we compared 2D and VR learning? 2D is a well established technology in education, and it is widely used in e learning, while VR is an emerging technology with the potential to enhance science education by improving engagement and learning outcomes. But despite this promise, its integration into K 12 classrooms through structured pedagogical framework remain underexplored. We try to bridge this research gap by using cognitive load theory and analyzed the intrinsic, extraneous, and germane loads by employing the technique of discourse analysis. Discourse analysis is a qualitative method for studying authentic language data, and it helped us to gain insights into how emerging platforms can better support diverse classroom settings. Our research questions were: what cognitive load challenges do K 12 learners experience while working on the same science experiment in 2D and VR? And how does cognitive load in VR designed online science experiments compare with 2D simulated experiment? What feels different when doing the same experiment in 2D and VR? For this, we took a grade 7 chemistry experiment from India's National Education Board and designed it in both the modalities 2D and VR. The experiment demonstrates the presence of carbon dioxide in the air by turning lime water milky, and it used distilled water as a control. It was a between subject study where 12 middle school learners were considered, were the participants, and they were randomly assigned 2D or VR experiments. The participants were engaged in a 30 to 45-minute session, which was divided into three phases. In the pre simulation phase, we checked their prior knowledge, introduced the experiment, and took them through a guided interaction. In the simulation phase, they conducted the experiment with minimal intervention from the researchers so that we could just observe their think aloud protocols. And in the post simulation phase, we try to understand what cognitive load they have experienced and what is the understanding of the experiment through structured questions. We use discourse analysis to explore their intrinsic, extraneous, and germane cognitive loads, and it was focused on researcher observations, think aloud protocols, and the audio and video transcripts. which we could take uh, from the recording. Based on these loads observed, patterns of cognitive load emerge, which were then put into in vivo coding. And we then analyzed the frequency of in vivo codes, which was represented by color code indicator bars. Here, the red color represented increase in cognitive load, green color represented decrease in cognitive load, and no color represented no contribution to cognitive load. How did the students process 2D and VR differently? Findings reveal key insights into cognitive load dynamics. In VR, intrinsic load was generally low because most had prior knowledge, but there were occasional spikes due to concept complexity. The extraneous load was high due to virtual object manipulations and task complexity. For example, one student found the experiment fast, and she said that experiment was going a little fast, so which indicated that she needed more processing time. The domain load was high as the students were actively engaged and could understand the key relationships, and it led to deeper processing and meaningful learning. In 2D, intrinsic load was low because some of them had prior knowledge. However, there were occasional spikes due to concept complexity. And also, due to the intuitive use of mouse and touch, it was a seamless interaction for them. Extraneous load was very high because of the object positioning, and the execution task seemed quite demanding for the children. The domain load was high as the learners integrated new information. So here are the key results at a glance. We can see that the germane load was higher in both the modalities, but it was the most learners understood through the VR. Like it could lead to deeper learning. 5 out of 6 learners could deeply learn the experiment, whereas here in 2D, only 3 to 4 learners could learn. Now, actual results can tell the real story. So this is the overall cognitive load VR experiment. And what we need to note here is the effect of these 3 loads on the overall cognitive load. As we can see, the increase or decrease in extraneous and intrinsic load has the same effect on the cognitive load, overall cognitive load. But if there is an increase in germane load, it is lowering the overall cognitive load, because germane load is actually a good load which leads to deeper learning. This is the overall cognitive load in the 2D experiment. We can see the extraneous load increased due to instructional pacing and task complexity. And in the germane load, though it is lowering the cognitive load overall, but we can also see uh, some you can see some bars which do not have any color. So this means that the understanding did not go deeper, and there was no contribution to the load for these learners. Okay, so what can we take away from this? There are some key takeaways. Intrinsic load in VR was mainly due to the novelty of the experiment, but it also kept the learners engaged. Like they were very motivated to do the VR experiment. In 2D, it was easy and seamless due to the intuitive mouse and touch. Extraneous load was higher in 2D than in VR, and we also found that emotional distractions are felt more in 2D than VR. This also shows that a smarter instructional design and facilitator support can help in both the environments. Germane load was higher in VR than 2D, which means that VR can actually lead to deeper learning. So we can conclude that VR enhances engagement and schema integration, but it requires a better task design. 2D is more accessible and user-friendly, but it has a higher extraneous load from interaction mechanics, and facilitator support would be crucial for both the modalities to enhance learning. These findings can apply to all basically designed for K-12 education, but they're also relevant for other fields like medical training. And reducing extraneous load through pre-training and improved VR design can enhance our learning. So where do we go from here? The future of immersive learning is just beginning. Imagine a VR science lab where gestures replace controllers, interaction seems natural, and AI gives real-time feedback tailored to each student's needs. This way, by enhancing VR with gesture recognition, intuitive controls, and AI driven adaptation, learning can become seamless and personalized. Future research can involve more larger scale studies on quantitative assessments to measure cognitive load and analyze prior VR experience effects on the cognitive load. In this way, by refining technology and research approaches, we can unlock the full potential of immersive learning in the metaverse. Thank you for your time and attention. I really look forward for more insights and further research opportunities to advance immersive learning.
Yes, thank you, ma'am. Just want to know means what is the motivation while selecting this problem statement? Just want to.
We are actually already seeing the 2D environments being like used widely adopted all over like the STEM education. And VR is an emerging technology which we can see in international schools in K-12 education, but it is yet not of like large scale adoption. So, and metaverse is already doing it. It's redefining virtual boundaries, and we can see avatars and all that. And also there is some literature which says that VR is actually helping students in education with the help, like it is improving their memory, recall, comprehension. So we thought to compare a traditional modality which is already used with an emerging technology, and how it can be like it can create new things for its STEM education in the future. So this is just a step which will actually go forward to a larger study.
Okay. So any challenges do you faced while implementing this?
Mm, Actually, when we employed this discourse analysis, challenges were like not exactly like that, but this is like just my reflection when we had conducted these things. Two interviews we conducted, three phases, but these two modalities, uh, we saw that children were like more inclined to VR education, like they are taking it as a with very high motivation, but at the same time we could understand that like it will take some time for them to adapt to the environment. Motivation levels are high, but similarly in 2D, when they were working in 2D, their motivation levels were not very high, and we saw that some children, like one or two learners, got emotionally distracted. Like they had perceived that they don't know the answers, so they were emotionally distracted, and this emotional distraction was felt more in 2D than in VR. VR also, there were some like one child who did not have the prior knowledge, but even then she was highly motivated to go through the experiment. But here in 2D, like if a child does not, like if a child is emotionally not very well inclined, so that will be felt more like he that demotivated her for further learning. This is what I saw.
Yes, thank you, ma'am. Thank you so much.
Thank you so much.
Thank you, ma'am.
Thank you.
Up next, we have Wei Zhao. She is presenting paper title From States to Changes, a Fewer Sensor Data Framework for Emotion Prediction. Ma'am, are you there?
Right. Yes.
Okay, ma'am, you can start your presentation.
Right. Thank you. Hello, everyone. My name is Zhao Wei. Today, I want to share my paper. The name is From States to Changes, a Pearson's data framework for emotion production. I will share my research from this four part. The first is the introduction. About 1 in 8 people in the world live in the mental disorder like this picture, and the mental health issues are becoming more widespread globally like this picture. But what was worse is that a large number of people didn't receive help in time. This brings us to the question, is it possible to know in advance whether your mood is going to worse or better? This is the emotion change. But now there are two challenges. The first is the static and the change. If we can know in advance whether our mood will get better or worse, we can take action. But now Many studies focus on static emotion states. This is not enough. We need to detect emotional changes. The second challenge is that subjective and objective. Most emotion studies rely on subjective input. However, subjective data is often inaccurate and biased. In contrast, objective data, such as the sensors, is positive and real-time. So, my research is focused on use only this objective data to predict changes in emotion. Our research goal is predict emotion changes using sense data only, and our data source is the sensor data from smartphones and smartwatches. We use these two tools to predict upcoming emotional changes, and it is involve early and non-intrusive mental health intervention. The next part is the methods. I use the dataset as student live dataset. This is an open dataset. Include 4 years mobile sensor data, include light, location, sleep, state, and so on. In this dataset, they use the palm as an emotion assessment tool, like this picture. This have 16 photos. The participants choose a photo that best describe how they feel right now. In my research, the input is this 4 part, and the output is emotion change. Like this is the real sense data. They capture features from mobile and wearable sensors. I use this real sense data to calculate the statistical features like mean, standard deviation, and skewness. The target of my research is emotion change. Like if we want to get the day 6, we want to emotion change days 5 and day 6. And if the lake window is 3, we need to previous 3 days the sense date. And the last part is abnormal detection. Like this part, if the sensor data in this part, I make it as 1, this is normal sense data. And if they exclude this part, I make it as 0. And in this part, make it as 2. I use this abnormal detection emotion in the input as the input date. Another problem is that most symbols belong to the normal classes, like this one. So I use the smarter and a Dyson generator synthetic symbols for extreme classes to balance training data and improve the model's sensitivity. For the method, I use the assembler in ensemble method combine multiple base models to achieve a better generalization. The gene ensemble methods, this 3 is the famous ensemble methods. So I use these 3 methods in my research. I choose this 3 method as a base model. Like this picture, we can find this 3 method is frequently used and strong performers in motion production task. So I choose this 3 as a base model. And
In my research, I finally choose baseline this method and begin stacking because SGB boost and kit boost is boosting. So in my research, I only use begin and stacking. So this is all my research method in my research I used. The next is the result and analysis. I use this 3 MSE, extreme MSE, and accuracy in my research as evaluation metrics. The first one is I needed to choose the optimal leg window. Like this is the MSE and extreme MMC, or this 3 baseline. And we can find 5 and 7 is the G5 and 7 window, we can get the best performance. And for the accuracy, we can find if the window is the 5, we can get best the performance. So combine the accuracy, MSE, and extreme MSE. Finally, we choose the 5 as the leg window. After we choose the leg window, I needed to combine all the methods, combine the performance. In this picture, the MSE and the extreme MSE, we can find this method stacking. This method is perform the best. And about the accuracy, we also find this method is best. So whether it is the MSE, extreme MSE, and the accuracy, this stacking performs the best. Last I also combine baking and stacking. Like this picture, we can find the stacking. Whether MSE, extreme MSE, and accuracy, stacking is perform best. So this is the best choice to predict emotion changes. And about this begin, this begin is was this is not a portion, and it is even worse than baseline. So begin is not an opposition. The last is the discussion and the conclusion. In my research, the motivation is when we wanted to know emotion changes in advance and have much time to interview, and we needed to use objective instead of subjective. So my goal of my research is predict emotion changes use sensor data only. I use the student life data set and ensemble methods and baseline in my research. And the key findings, the first is the leg window is 5. This window is the best window. And the stacking, this method is the best model. And the begin performs worse than baseline. This is not suitable for this task. In my research, the contribution is first we predict emotion changes using peer sensor data only, and employs extreme emotion change as a valuable signal, not noise. In the future, I will conduct real-world intervention studies based on predicting emotion and link emotion prediction to mental health outcomes or support behavior. That's all. Thank you.
Yes, thank you. Can you explain what is the difference between MSE and extreme MSE?
Okay. MCE is the okay. The MSE is the overall prediction error, but extreme MSE will focus on the large emotional shifts. If the change more than 10, we calculate the extreme MSE. If not, we only compute the MSE.
Okay. Do you know about the XGBoost algorithm, how it works?
You know state box accuracy?
Yes, XGBoost model, machine learning model.
Yes, you means in my research, my baseline, my baseline is this three methods.
Yeah, but how would this model works, XGBoost?
Yes, I in my research, I use some features input, and then we get the we get more and more numbers. On the numbers is that the palm value.
Okay, thank you. Thank you.
Thank you.
Thank you. After this, we have Zaimanu Dongri. She is presenting paper titled Harnessing Geospatial Tools for Urban Heat and Land Surface Temperature Analysis in Tamil Nadu. Ma'am, are you here?
Hello.
Yes, ma'am, you are audible.
Yeah. So today, me and my teammates Zia and Swara are going to present a paper on harnessing geospatial tools for urban heat and land surface temperature analysis in Tamil Nadu under the guidance of Dr. Jayashree Khanapuri ma'am and Dr. Sarguna ma'am. Next slide, please. This is the outline of our presentation. Yeah. This research focuses on understanding the land surface temperature fluctuations across Tamil Nadu and exploring how rapid urbanization changes and affect the local climate. The LST data offers key insights into how heat is radiated from the Earth's surface and helps tracking patterns and urban shifts. By analyzing the LST variation and their correlation with the land use pattern, this study provides insights for sustainable urban planning and environmental conservation and adaptive climate strategies. Next slide, please. The objective of a paper is to analyze the LST variation across Tamil Nadu in the key frame of 2018, 2020, and 24 using multi-temporal landscape imagery. This study evaluates the LST changes over this time frame. The long-term analysis helps uncover how surface temperature have evolved and identifying the spatial and temporal trends in temperature rise across different land use type, urban, agricultural, forested, and barren land. By mapping these trends, we can correlate the LST changes with urban expansion and vegetative cover loss. And based on this observation, the study proposes actionable mitigation strategies such as expanding green cover, adapting reflective buildings materials, improving water management, and incorporating climate adaptive designs. Next slide, please. Extensive prior research has established a strong correlation between urbanization and the rise in land surface temperature, contributing significantly to the urban heat island effect. Similar case studies across Tamil Nadu, including Kanyakumari, Coimbatore, and Chennai, have been demonstrating this trend. In Coimbatore, for instance, a 4-degree LST increase was observed across just 5 years in the build-up zones. And on a global scale, also, this research has consistently shown that deforestation and increased surface coverage and reduced vegetation can significantly affect the UHI conditions. This study builds upon the past findings by focusing on Tamil Nadu's urban expansion trends and this direct impact on surface temperature using advanced data analytics for deeper insights. Next slide, please. The study area of a paper is Tamil Nadu. It is bordered by Andhra Pradesh, Karnataka, and Kerala, and has a water body impact of Bay of Bengal on the east. The tropical climate, the state experiences a tropical climate with seasonal monsoons and diverse geographical features impacting the temperature. The LST analysis, as discussed earlier, is across 2018, 2020, and 24, assessing the urbanization and climate change. The rapid urban growth increases the LST in cities, while in rural areas we can see that the temperature is at a lower due to vegetation and water body effect. The Landsat 8 thermal band are resampled from 100 to 30 meter for thermal landscape insights and better data. Next slide, please. In this paper, we have used the MODIS data for LST analysis and Landsat 8 imagery using analytical tools such as Google Earth Engine and USGS for high performance computation and ensuring efficient processing of large data sets. The machine learning model we have used is random forest for LULC, and we have used gradient boosting, enhancing the LST precision for data accuracy and reducing error while improving the trend analysis by using open source libraries and geospatial libraries like Folium, GeoPandas, and NumPy for handling data, processing data, and Matplotlib for visualizing the data, and integrating APIs for enhancing the geospatial data and getting a better spectral analysis. Next slide, please. I would like my teammate Zia to continue further. Thank you.
Thank you, Vidisha. Carry forwarding to data analysis and processing. This study analyzes the LST variation using multi-temporal satellite imagery for the given years with radiometric calibration and atmospheric correction in GEE, that is Google Earth Engine. This also identifies the correlation with the urbanization and water bodies vegetation, aiding sustainable urban planning and climate adaptation strategies. To enhance the urban resilience, the study proposes expanding the green cover and reducing pollution, improving water management to mitigate the urban heat islands, which is observed in Tamil Nadu. Next slide, please. So here's a result of the LST analysis, which can be observed for the March month for the year 2024. The selected is timeline is daytime. This can be switched between the daytime and the nighttime and varied across the months of March to June for the given years. And we can see how the temperature has been displayed for the different parts of the Tamil Nadu. Next slide, please. The same has been done for the nighttime region, how the temperature is reduced from 47 degrees maximum being to approximately a range of 27 degrees during the night time. Next slide, please. So here is the LULC mapping, that is land cover and land uses mapping under Tamil Nadu for using the level 2 classification having 17 types. We can see how the major occupied land cover is croplands and its effects on the Tamil Nadu, accompanied by the various other land users. Next slide, please. So here is the different maps between 2018 and 2020. This can be varied amongst the combination of other 3 years. The blue region shows how the region has shown the colder drop in temperature as compared to the previous year, whereas the red region shows the temperature has significantly increased as compared to this previous year, whereas the white region shows there is no significant change in comparison to it. Next slide, please. So this time series map gives a exact temperature value for the given dates from March 1st to the 30th June timeline, and this can be obtained for the whole Tamil Nadu state or for a specific district. Here we have taken only specifically for the Tamil Nadu state, and it can be varied between the daytime and the nighttime. Now I'll call upon Swara to carry forward the next presentation. Thank you.
Thank you, Zia. Here is the daily land surface temperature comparison daytime for Tamil Nadu of the year 2018 and 2020. The findings demonstrate a noticeable increase in temperature levels, primarily resulting from rapid urbanization and decline in vegetation cover. This upward trend signifies the growing environmental burden on urban areas and underscores the pressing need for well informed and sustainable urban planning practices. Next, here is the prediction analysis for Coimbatore district. Now proceed to the 2024 year land use land cover prediction for Coimbatore district. The analysis projects a subtitle rise in build up areas coupled with reduction in both vegetation and forest regions. This changes place increasing stress on cities' natural environment and contribute to the urban heat island effect. The results further emphasizes critical importance in incorporating green infrastructure into long-term development policies. Next is the policy
Sorry
implications
to
and
interrupt, ma'am.
recommendation.
Your 9 minutes are over. So please kindly wrap up your presentation.
Here is the green infrastructure, sustainable construction, zoning regulation, smart water management. Policymakers must look into it to collaborate with environmental experts and local community to balance the ecological system. Here is the future scope and announcement. Looking forward, future direction of this research involves refining predictive models through utilization of advanced artificial intelligence and machine learning algorithms. The Tamil Nadu will contribute to more improvised understanding of regional dynamics. In conclusion, I would like to say that this study offers meaningful insights into involving patterns of land use and temperature. Throughout the strategic applications of geospatial analysis, advanced based policy suggestion, and emerging technologies, urban development can be directed in a manner that is both environmentally sustainable and capable of withstanding climatic changes occurring in the nature. Here are the references we have used in our paper. We are open for Q&A and discussion. Thank you.
Okay, what are the real applications of your work where you can use? Yes, I'm audible.
Basically, we can use for developing cities because the UHI, the urban heat index, is increasing due to the deforestation occurring in the city areas. For that, well planned infrastructure and policy is needed.
Okay. Why you choose gradient boosting machine learning algorithm?
Hello, am I audible?
Yes.
Yeah, so gradient machine learning algorithm is used as it minimizes the loss function which is seen in the temperature across the state, and with modest data we observe that many of the date ranges temperature values were missing, and to identify a perfect data set, gradient machine learning algorithm was a perfect fit, wherein it was moving to the opposite of the gradient and the perfect giving us the perfect graph of how many days has the maximum uh, values of the temperature taken throughout the days. And yeah, with the minimum loss function we found out that with gradient machine learning algorithm we can go with the perfect fit.
Okay. Have you compared with any other model?
Yes, we have compared with the logistic regression and the other models with random forest also. But we have also implicated random forest algorithm in our project as well.
Yes, thank you.
Thank you.
Thank you, everyone. After this, we have Y Darshika. She is presenting the paper title Multimodal Deepfake Detection Using Deep Learning Models. Y Darshika, ma'am, are you there?
Yes, sir. Can you hear me?
Yeah, you're audible. Just a second. Yeah, now you can share your screen.
Yeah, sure. Can you see my screen?
Yeah, it's visible.
So, greetings to everyone. I'm Darshika from Sona College of Technology, Tamil Nadu, India. Here to present my paper on the topic of multimodal deepfake detection using deep learning models. Before going into the presentation, I would like to tell an example. So, imagine an employee is getting a call from his manager to urgently wire some money to a vendor. So the employee he recognizes their voice and tone, and he does the task as his manager said. But later on he decides that his the call that he have got is not by his manager, and it is an AI predicted voice. So this is a deep fake. So in today's world, deep fakes are prevalent in and around. So we built a model, uh, multimodal deepfake detection systems to tackle these problems in the today's era. Starting on with it, my paper presents the multimodal deepfake detection system, which utilizes deep learning models to detect the fake media contents across four modalities, namely image, video, audio, text. So the traditional detection methods only focus on one type of inputs, which are prone to errors, and the attackers are easily pose threats to using the cross-model functionalities. So to avoid this, we propose models like YOLO V8 using the CNN's algorithms, and wave to vectors using the RNNs, and BERT transformers to predict the image, videos, audios, and text models. So this system is designed for the real-time applications and offers a modular expansions to the future threats. So the fake could be reduced. Coming on to the introduction part, so deepfakes are nothing but an AI generated fake medias. So there are more serious threats in and around the world in the areas like elections, cyber securities, social media frauds, fraudulent calls, and emails. So, and the existing models are built up with only a single model. For example, if we take an video, it only analyzes the predictions for the video frames depicted from the videos, but it doesn't analyze the audios and the text detected from it. So our goal is to build a multi-model which analyzes the videos, extracts the audios and the text, and detects the deepfakes clearly. So the need for the project is the single model limitations, and for high accuracy and for the real world applications, we have been introducing this model. So according to the literary survey analysis, we have analyzed that the existing systems versus the proposed system that we are going to do. So the existing system is built up with a single model, and our proposed system comprises of cross-model functionalities. As I said earlier, the video depicts only the image frames, but our model predicts the audios from the video and the text analysis also. And the existing system also predicts less accuracy and precisions, and our proposed system predicts more accuracies of the deep fakes. and the existing system would easily prone to the attackers since it lacks the cross model functionality. So this attacks and threats could be prevented from our system. Next is the overall architecture diagram of our model. So we are inputting the text, audio, images, and videos. So these are being trained using the deep learning models like the YOLO CNN algorithm, which uses the YOLO V8, and RNN, which uses the wave 2 vectors. And for the text, we are using the transformers, BERT, and Whisper AI. So these results are fused into a layer that predicts the deepfake detection results. So these are the explanation. So the multimodal approaches, we are importing the data and we are training the models, and we are fusing all into a cross-model functionalities. Then we are predicting the output, which is easy for the end user to analyze the deepfakes. So first, in our methodology, we are collecting the data and pre-processing the data sets, and we are extracting the features from the data sets, and we are fusing into a multimodal, and we are classifying them as real or a fake. These are the modules split up of our work. The novelty comes of for our project is that we detect the eye blinks of the images and videos, and the pitch shift of audios, and the text inconsistencies for better accuracy. So the existing system fails to predict the accurate predictions, and our model fine grains the model analysis. And we have the cross model validations, which gives a stronger evidence for our models. Then it adjusts the model sensitivity based on the media qualities. So these are the outputs of a model prediction. First is the text that tells us the fake and real contents. Next is the audio graph of the fake and the frequencies of the fake and real. Then videos, the blue lines indicates that it is a real, and the red lines are the fake. And the output of the image, that is the real and fake. So our output of a text and audio, which predicts the real and fake of each data sets. And a future enhancements that we are implementing and manual prompt analysis is in case if an individual user inputs any models like image, video, text, and audio in he would be able to identify the confidence scores and accuracies with a real-time detection. And also adding on to it, we are implementing an explainable AI bot, which highlights the visual impacts of fakes, and also text explainable to identify clarify the reasons behind its predictions. And the trust score and feedback, it displays the detection probability and integrates the user feedback for continuous model improvements. So these are our references that we have gone through and we have analyzed for the existing and proposed. So in conclusion, I would like to tell this multimodal deepfake detection system integrates the modalities with advanced deep learning models like CNNs, transformers, RNNs to detect the deepfake inconsistencies. So this has been introduced because of the enhancement of the enhances the cybersecurity, medical forensics, and misinformation preventions with a scalable real-time detection systems. So this multimodal deepfake detection system research paper would be useful for all the areas where the fraudulent actions have been arising, and it would also be useful for the social media, and for the even more for the celebrities and all the famous persons. So this it would be useful for detecting the fakes. Thank you. I'm open up to questions.
Okay, which CNN model do you use?
For the CNN algorithm, we have used the CNN algorithm YOLO V8, ma'am.
Okay. Have you tried other algorithms of CNN?
Other algorithms, ma'am?
Yes, resonate or other end.
As of now, we have tried with YOLO V8, ma'am.
Okay, okay, fine. Yes, thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Up next, we have R. Anand, and he is presenting the paper title Railway Track Obstacle Detection and Alert System Using Deep Learning. R. Anand, sir, are you there? R. Anand, sir, are you there?
Yeah, sir. I'm there.
Okay, sir. You can start your presentation, sir.
Okay.
So, are you R. Anand or you are presenting on behalf of R. Anand?
I'm one of the authors, Monish TP, and my team members are also there in the call.
Okay, sir.
Okay, can I share the project?
Yeah, sir. Just a second.
Oh, okay.
Yes, sir. You can share now.
Oh, okay. Okay. Good morning to one and all present here. Good afternoon, basically. So, our project title is Railway Track Obstacle Detection and Alert System. So, these are my team members, Monish, myself as Monish, my team members, Madhukar Pari, and our supervisor, Dr. Anand. So, it's a professor of Department of Computer Science and Engineering at Isha Engineering College. So, our project title is Railway Track Obstacle Detection and Alert System. So, railway track obstacle detection and alert system is basically a system enhanced railway safety by detecting obstacles in real time and providing time alerts. It's basically a safety measures which is taking in railway department. We enhancing the features. It's also day by day. This all the things are there in railway features, but we are existing solutions where the conventional surveillance methods of for a human monitoring, which are prone to delays and inefficiencies, leading to potential accidents can be covered over it. To address these challenges, we declare a novel detection framework by designing a railway track detection camera by fixing a camera. We can enhance the accuracy of the camera while detecting the object. We can save many lives and we can defend many accidents to get all over. And also we are using IoT and cloud computing for real-time processing and remote monitoring for ensuring seamless communication with railway authorization to immediate response. So our objectives is to enhance the railway safety, implement fine-grained access control. To enhance rail safety means we develop a robust system like a real-time reducing the risk accidents by focusing on which type of objects we can easily transfer the data where the camera actually responded to it and it sends a notification to the train alert or the departure, which we can control the accidents or the intermediate cases. So implement fine-grained access control, utilize AI-based image. So we are inserting around thousands and more thousands images in SSD and BG60. It's a main composed of our project. So let's see in the next slide around what is that. Now its objectives leverage cloud computing. We are using a IoT-based cloud system, which the message leads to the nearby stations and control system, support such functionality. So extended design in fact notification system, which is alert the train operators to there's a obstacle detects in front of us. So our motivation is security and privacy risk, where a railway network face frequent accidents due to underrated obstacle and tracks. It's a day-by-day society. We can see many accidents today or tomorrow can take place. By our feature is extant, but we are implementing a new resource of IoT and taking BG16 and SSD into another level to respond the accuracy and the controlling of the death rate of the railway accidents can be lower by using our project, a railway track obstacle detection, a limitation of current access control. So existing surveillance and manual inspection methods are slow, inefficient, and prone to human errors, making a real-time detection challenging. Need for a secure, efficient solution. We have a solution called Smart AA-driven obstacle detection, where an alert system is essential to enhance the railway safety by ensuring the timely identification and response to the potential hazards. So these are the literature survey we taken from, we already have it from the kind of project. We are taking from the IoT system-based vehicle tracking and emerging response by using GPS and technologies and IoT-based accident detection and recycle system using sensors and mobile communication technologies and their attributes and the challenges. But we are showcasing this for the more accuracy we are providing is more valuable in this case. So the is the next literature survey. They are also giving the same type of accuracy in this. So now we're going to see about the issues in the existing system. So it's about the lack of fine-grained access control. It's basically a traditional system rely on a periodic manual inception, leading to delay in detecting obstacles on railway tracks. For basically, see, we have issues, but we can control the detection process and delays when we can give a maximum accuracy level to predict to control the accidents. And also the vulnerability into inference attacks to existing detection method often produce false positivity and causing unnecessary distributed railway operation is basically around the railway tracks and operations between them and inefficient encryption methods. Many current solutions lack advanced AI-based techniques, but AI is coming developed by these resources by day. But when we implement in railway tracks, we can stop many accidents and the detect can be low down and several animals and people life can be saved by the thing. But we have lack of inefficient encryption methods. But we can improve the accuracy by changing it into high number of processes giving to it. Lack of privacy in cloud processing. So when we take IoT, the sending timing is a little bit low due to the weather conditions and the alternate pauses of we are going to think and limited support for secure search. Deploying advanced monitoring systems with existing infrastructure can be expensive and difficult, but we can improve our quality and accuracy by day when we launches the scheme. So our proposed system. Our proposed system.
I'll take over. So here we have the proposed system. The proposed system basically talks about the real-time obstacle detection. So when we talk about obstacle detection, our main goal is to detect any obstacles in the railway track so that we can avoid any collisions in the railway track. So the proposed system basically involves the first step as real-time obstacle detection. Then we're going to identify the obstacle using AI and ML algorithms, namely SST and VGG16. After that, we are also planning to implement the automated alert system, which sends the alert to the railway controller, who then can decide whether or not to stop the train depending upon the obstacle. Similarly, we can do this integration with IoT and cloud for faster data sending and so on. Next slide. So this is the architecture diagram over here. So we have the railway object data set, meaning like this is the image that is going to be captured. So once the image is captured, the image pre-processing done, like feature extraction and so on, for the model to identify the object. So SST stands for single shot detection, and it identifies the object. Once the object is identified, VGG16 is then used to classify the object. For example, in some cases of small objects, for example, like stone or something on the track, once it is identified and classified, we not need to stop the train because those are very small objects and will not cause an impact. But in case of larger objects, we need to stop the train. So that's why we are actually using VG16 to classify the objects. And once the objects are classified, then depending upon the object, we decide whether or not to stop it. Next slide. Next slide. So these are the list of modules. First, we have the obstacle detection module. Obstacle detection module uses sensors and cameras. So sensor is like the ultrasonic sensor we use for normal testing to detect objects. And when implementing in large scale, we can use LiDAR sensors for better accuracy and for better object detection. And similarly, we can use cameras to identify objects. That is, we saw on the previous slide about the architecture diagram. Once the images are like the obstacles are detected, then we move on to the image processing and AI module. So here the image, which is now in frames, will be sent to the algorithm, which will in turn classify the object, and depending upon that, we will also send the data to the controller using the Internet of Things and cloud communication. Next slide. So module on obstacle detection system. So real-time obstacle
Sorry
detection
to
system.
interrupt, sir, but your 9 minutes are over, so kindly wrap up your presentation.
Okay. So obstacle detection system, basically we talked about it. So we used SST for obstacle detection system, and our SST is has better accuracy than the existing models. That's why we went for SST. Next slide. So after image processing is done, we then send the data to Internet of Things, and we can also integrate cloud when we're implementing large scale. For cost reasons, we can use Internet of Things as well. Next slide. So this is the functional architecture. First one involves data acquisition, that is capturing the image. After that, it is pre-processed. Then the second layer, AI detects the objects and classifies the object. After that, alert is sent, and then depending upon that, the train is stopped over. The rest is sent. Next.
Algorithm used. Okay, as for the algorithm use, we use a VG16 SST. It's a powerful deep learning architecture pre-trained on ImageNet. First, we extract the features from the railway track obstacle images using the VG16, which helps us the system to understand the key patterns. In the first stage, the model determines whether the image input actually contains a railway track. If the track is detected, it moves on to the second stage, where it classifies the track is clear or not, and to ensure the better performance and faster processing. We apply the real-time image pre-processing technique, such as resizing the image to like 224 into 224 pixel, converting into the grayscale. So yeah, these are the implementation. We brought all the core components for image processing with AI and IoT and cloud integration into unified working system. We use a sensor and camera to capture the real-time data, which is then processed through our AI model to detect the obstacle accurately. This system was developed using NetBeans and coding like Java, SQL, so on. Next slide. Next slide. As for the performance evaluation, in terms of performance, we test our system with different scenarios to ensure the accuracy and speed and reliability. The obstacle detection algorithm shows high precision in identifying the real threat, with significantly reducing the fall alerts. System requirements. So basically, we use Python, Java, SQL to build our system. This is our project demo. As you can see, it's able to detect the track, and also if there is any obstacle, it also send the alert message to the email or IoT platform. Thank you.
In result analysis, you are showing accuracy as 1. So which metric you are using for accuracy measure?
We have not implemented like any particular thing to measure accuracy, ma'am. But basically, SST in general, like when we tested out with multiple images, it has shown better accuracy than the existing models.
Then what is the graph? I mean, what graph you are
So the
writing
graph.
epochs versus. So have
Oh,
you
sorry.
tried or not? Epochs.
Yes, ma'am. So this graph is basically the accuracy from the labeled data sets. So once we train the model with the labeled data set, then we test the model with images from the data set, and we see how it labels them. And depending upon the labeling, we calculate the accuracy.
So you are getting 1 for all epochs, right?
No, ma'am. As we go higher and higher, like on the first epoch, we do not get 1. As we train for more epochs, we get the accuracy eventually.
Okay. What is the use of that sensor data? Why you are using sensors?
Yes, ma'am. So when in case of cameras, there's always a potential for failure due to the reasons. So for double safety, we are implementing sensors as well for more safety. So in case of rain and so on, the lens may get fog or something. So for that reason, when we implement sensor, we can also detect objects through sensors.
Okay, so that sensor will be attached to railways, right?
Yes, ma'am.
Or
On the train, in front of the train.
okay, okay, fine. Yes, good work. Thank you.
Thank you.
Thank you, ma'am. Thank you.
Thank you, ma'am. We are just moving forward.
Thank you, team. Up next, we have Palagani Sai Mansa. She is presenting the paper titled YOLO V8 powered helmet, license plate, and rider detection with real-time safety check and fine assessment.
Good afternoon, everyone. I'm Palagani Saimansa from the Department of Computer Science and Engineering. Today, I'm going to present my project called YOLO version 8 powered helmet, license plate, and rider distraction detection with real-time safety check and fine assessment. This project was guided by our guide, Dr. T. Balmurli Krishna sir. So in this presentation, I'm going to explain about our project abstract, introduction, problem statement, solution space, literature survey, system analysis, system design, system testing, results, conclusion, future scope, and downs clarification session. Coming to abstract, the main idea of this project is to reduce manual traffic monitoring by using AI and computer vision. We use YOLO version 8, a powerful object detection model, to identify if the rider is wearing a helmet and if they are distracted or not. We also used OCR to extract license plate details. For this project, we have gained an accuracy of 95.5%, which shows our system is highly reliable. So coming to introduction, road accidents caused by helmetless riding and distracted driving are very common, especially in countries like India. So manually monitoring all these violations is hard for traffic police. So for that, we have developed a automated system using deep learning and computer vision, which uses YOLO version 8 algorithm. It also covers extra features of assessments of fines for traffic violations. It has a few improvements based from different versions. Coming to problem space, it enhances the traffic safety and management through automation, utilizes deep learning and computer vision for real-time detection, identifies helmet usage, detect license plates. It also calculates fines for violations, also contribute to improved road safety. So our problem statement is currently traffic rule enforcement is manual and time consuming. There is no efficient system for identifying violators in real time. Our project solves this using AI models to automate detection and reporting, making it faster and more scalable. So for this problem, we have proposed a solution using an automated deep learning based system using YOLO version 8 for real-time detection for helmet violations, rider distractions, and license plates. This system operates in three modes: image mode, video mode, and live camera mode. It uses paddle OCR to extract data from the license plate. It also has a fine assessment module which automatically calculates penalties for the violations. We have used Flask-based web interface for traffic authorities to monitor violations. So, coming to literature survey, we studied existing systems that used older versions of YOLO or other detection models. Most of them could only detect helmet usage or number plates or not both together. So, we have used both the functionalities in one system. This is our proposed system. Coming to the algorithms we have used YOLO version 8 algorithm for a real-time object detection. It is a real-time object detection algorithm used for detecting helmets. And next is a OCR optimal character recognition algorithm for recognizing and extracting text for the license plates. Next is CNN algorithm. It is a classification algorithm for determining whether the person is wearing a helmet or not. Next is OpenCV. It is a library to display fine amount on the processed images or videos. We have used a rule-based system to calculate fines based on the violations. Coming to system requirements, the requirements we need for software are: operating system is Windows 10 or 11, coding language is Python, web framework is Flask, front end is HTML, CSS or JavaScript. Hardware requirements, we need i3 processor and 500 GB hard disk. Storage, monitor is 15 inches LED. Input devices are keyboard, mouse. RAM is 8 GB and camera is web camera mode. So coming to system analysis. In system analysis, first one is system workflow. This diagram shows how the system works step by step. First, the input is taken, then it is passed to YOLO version 8 algorithm. It checks whether the person is wearing a helmet or not and whether he is distracted or not. Based on that violations, It calculates fine and displays the result. Next is system usage. System usage is also known as use case diagram. Here in this system, there are two actors. First one is user and second one is system. Your user is responsible for uploading data and viewing the output, but system is responsible for analyzing data, detections, calculating fines and generating output. Next is software design. In software design, first one is system design. System design is also known as architecture. In our architecture, there are 4 layers. First one is presentation layer. In presentation layer, we have created UI using HTML, CSS and JavaScript. And in application layer, we have used Flask web server to integrate our system with UI. And third layer is service layer. In this service layer, we have used YOLO version 8 detection algorithm and fine calculation systems to calculate and detection for calculation and detections. Next is data layer. In this data layer, we are storing our data using the static database. So next is system interaction. System interaction, there are 4 steps in system interaction. First one is system initialization. The system starts and processes the input. Next is helmet detection. In this phase, the system detects whether the person is wearing a helmet or not, and if he is not wearing a helmet, it detects as a helmet violation. Next is direct detection, distraction detection. And fourth phase is fine calculation and result generation. Based on those violations, the fine is calculated and then the result is generated. This is the activity diagram. Next is system sequence. This diagram emphasizes the sequence of our system. First, the sequence starts from the user, next to the web interface, next to detection system, YOLO model, and fine calculator. In this way, the system calculates the system emphasizes detects whether the person is wearing a helmet or not. If there is a violation, it detects the license plate. This is the sequence of our system. Next is static structure diagram. Static structure diagram is also known as class diagram. This system is designed for automated traffic law enforcement, focusing on helmet detection, phone usage violations, and license plate recognition. It manages core functionality, handles video processing, and validates plate format. Next is system package. System package is also known as a component diagram. Here, this diagram describes the packages we have used in web application and client side. For web application, we have used Flask web server, and for detecting helmets and rider distractions, we have used a detection engine. And for image processing and video processing, we have used image processor in a web application. On the client side, for viewing the entire result, we need a web browser, for example, Google Chrome or Microsoft Edge. And we need a webcam interface for live camera detection. Next
Ma'am,
is
your 9 minutes are over, so kindly wrap your presentation.
okay, sir. Next is system topology. System topology is also known as deployment diagram. So, deployment diagram showcases the nodes we have used in our system. So next is system testing. Here in our project, we have tested 3 cases. First test case is ensuring the system correctly detects whether the person is wearing a helmet or not. If for our system, our system is detecting the helmet, so this test case is being passed. Next is test case is ensuring the system accurately detecting and extracting license plate numbers. So our system is also detecting and extracting license plate numbers. So this test case is also has been passed. And third test case is ensuring the system correctly detects if a rider is using a mobile phone or not, or engaged in any other distractions. So our system is detecting rider distractions. For example, if a person is using a mobile phone. So this test case also been passed. So this is the result. As you can see in the final result, our key performance metrics are: we have gained an accuracy of 96%, precision of 96%, recall of 98.5%, and F1 score of 90.2%. As you can see in those results, our model is robust and consistent. Our system is detecting a helmet. Here, as you can see in the image, the person is not wearing a helmet, but he is wearing a cap. So our system detected that he is not wearing a helmet, and it issues a fine of 100 rupees. And he is using a mobile phone. It also issued a fine for mobile phone, and it also extracting the license plate number. So for coming to future scope, in the future we plan to improve detection in poor lighting and crowded traffic, add detection for other violations, build a mobile app version for our web application, and offline functionality for low network areas. So coming to conclusion, our system automates traffic rule enforcement using AI. It's scalable and real-time and accurate. We believe this can bring a significant improvement in road safety and traffic monitoring. Coming to references, we referred to multiple IEEE papers and open source libraries during this development. These are the references we have gone through. Thank you, sir.
Okay, thank you, ma'am. Any challenges do you faced while working on this project?
Yes, ma'am. Actually, we have collected data. We have collected a custom data set, ma'am. So it is quite tough for us to collect data in different lighting conditions. It is the most challenging part we have faced.
Okay, and have you tried on videos?
Yes, ma'am.
Or is it working accurately?
Yes, ma'am. It has a high accuracy, ma'am. It is working accurately.
Okay, yes. Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Can stop your presentation. Yeah. So all the presentations are over. I sincerely thank you, our authors, for their excellent presentations and contribution in this session, and all our participants for being part of this international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for the support during the 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version of in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2025. I thank our session chair, Dr. Namrata Vasatkar ma'am, for chairing the session. A token of appreciation to the chair on behalf of team ICICT 2025 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence, ma'am. Ma'am, would you like to give any closing remarks?
Yes, thank you, Siddesh. It was great actually to review all these authors. Yeah, thank you. Thank you
Yeah,
to everyone.
thank you, ma'am. I kindly request you all to switch on the cameras for a quick snapshot for a virtual conference. Okay, thank you.